Good evening to one and all present here. I am Arundhati Mukherjee from Revered Media. We welcome you all to today's webinar on Potential of Industrialized Building Construction in Boosting Housing Market in India. This webinar is jointly organized by Builders Association of India, Mumbai Centre, and Civil Engineering and Construction Review. This webinar is powered by Revered Media. We would like to begin this webinar by welcoming Shri Mohinder Rijwani, who is the Chairman of Builders Association of India, Mumbai Centre. Sir, I would request you to address today's gathering with a few words.
Thank you, ma'am. Good evening, ladies and gentlemen. BAI Mumbai Centre introduced the concept of monthly lecture meetings in November 2019. Initially, they were physical events held in the conference room of BAI, but due to the pandemic, they became online. Till now, nearly 20 such lecture meetings and webinars have been organized by BAI Mumbai Centre, and they have all been well received and appreciated by all. Now we have on board Civil Engineering and Construction Review, popularly known as CE&CR, and its sister organization Revered Media. CE&CR is a long-standing construction industry publication and have a very good reputation. CE&CR and Revered Media brings them with them their in-depth expertise in this. I am sure the tie-up between BAI Mumbai Centre and CE&CR and Revered Media will be a win-win situation for all. For today's webinar on potential of industrialized building construction in boosting housing market in India, we have the highly eminent speaker, Dr. Bishwajit Bhattacharjee, eminent professor in Civil Engineering Department from IIT Delhi, as the keynote speaker. So I welcome you. Shri Sourabh Manjrekar, Director Technology of Sunanda Global, who is the son of our own Dr. S.K. Manjrekar, is the moderator. Shri Sourabh, I now only welcome you, but also wish you the very best and look forward to you to being involved in BI activity like your father. I would like to say, industrialized building construction is a prefab and precast construction up to a certain extent. With the sort of housing requirement in India, industrialized building construction will be faster, economical, and perfect finish. I will not dwell much on this topic and leave it to the keynote speaker and the moderator to enlighten us. I welcome all the senior functionaries of BI who have joined us here today. I welcome all the participants who have registered and are there with us today. I wish you all a very informative evening. Thank you.
Thank you, sir. Now we would like to present to you all CE&CR and Revered Media.
Civil Engineering and Construction Review, a leading infrastructure monthly on methods, materials, and machinery. Celebrating 34 years of publication. CE&CR is India's #1 infrastructure monthly news journal for the past 34 years. We have been providing discerning knowledge and an unmatched coverage of the construction sector since 1988. Get social with the largest online construction media network of India. Civil Engineering and Construction Review provides a valuable, informative, unmatched high-quality content. It is the most circulated magazine in India, having a readership over 17 countries worldwide. Google rank #1 under the search of Civil Engineering Magazine India and Construction Magazine India. We have a 5-star rating as well. Currently stands at 58,000 plus followers on Facebook. 16,500 plus industry professionals connected on LinkedIn. You can also find us on other social media platforms such as Twitter, YouTube, Instagram, and SoundCloud. No one around us in India. CE&CR has been awarded the prestigious Best News Magazine by CIDC in the year 2014 and 2019. Best Publication Award by the ACCEI in 1991. Designated for International Quality Summit Award in Gold category in Paris by BID in the year 2012. We cover topics such as roads and pavements, bridges, construction equipment, concreting, precast, high-rise structures, waterproofing, and many more. CE&CR is read by construction companies, contractors, builders, government departments, public sector undertakings, building material and equipment manufacturers, consultant and architectural engineers, research institutes, polytechnics and colleges. Connect with the most circulated and trusted magazine in India.
Introducing Revered Media, a 360 degrees logistics solutions of business events. Who we are and what we do. Revered Media is an independent, full-service, professional logistics solutions company for business events. We specialize in corporate events with end-to-end event project management. It's powered by professionals with over 30 years of substantial experience in this field, promoting and managing some of the leading events in B2B segment. This company will encompass professional, concerted and focused approach towards events. Our commitment is to see each event through from the start to finish, while keeping the goals, vision, budget, and our clients' needs in mind at all times. We handle all details associated with the event process, so you can focus on what's essential to you. We manage your events from conceptualization to execution, saving you the long hours, late nights, and endless emails. From venue finding to post-event reconciliation, with our team of experienced staff and logistical experts. Analyzing, planning, marketing, producing, and evaluating an event. Managed efficiently and effectively. Representing leading international exhibition organizers for promotion of their shows in India. Our unique selling proposition are, we have a focused and contemporary approach. Wide contacts in the fraternity with strong association linkages. Rich experience in conceiving and managing high-profile events. Working within deadlines and budget with maximum mileage. Strong marketing instincts, understanding and motivated team. Time-bound execution. With measurable output. We specialize in various types of events such as webinars, seminars, conferences, exhibitions, social media marketing, EDMs and e-newsletters, workshops, promotional advertisement and designing, public relations, product launch, award ceremonies, road shows and many more. Our vision includes growth, innovation, affordability, and quality services. Contact us and join hands with Revered Media.
We would like to thank Builders Association of India, Mumbai Centre for providing this opportunity to collaborate for this venture. We are hopeful that our venture of events will be a success. Introducing to you all our moderator for the day, Mr. Sourabh Manjrekar.
Mr. Sourabh Manjrekar is the Director Technology at Sunanda Global. He has worked at Sunanda for 10 years. Here, his specific focus is on developing sustainable solutions for large industrial and infrastructure projects, besides overseeing the company's global operations from its Dubai office. He is an expert on corrosion mitigation in steel and concrete structures and is regularly featured as keynote speaker by apex industrial bodies such as Confederation of Indian Industry. He has delivered over 60 lectures in more than 20 countries as part of his technical knowledge dissemination efforts. Most notably, he was invited to be part of the American Concrete Institute ANSI and ISO joint initiative of ISO TC71 for making a unified umbrella global code for concrete. Mr. Sourabh's papers on sustainability, corrosion mitigation and soil stabilization have been published in reputed national and international journals. He has received various awards such as Innovator of the Year Construction Chemicals in the years 2012, 2013, 2015, award by Department of Chemicals and Petrochemicals Government of India and FICCI. American Concrete Institute's Young Member Award for Professional Achievement 2020. He currently serves on the following ACI committees: Codes and Standards Advocacy and Outreach, International Advisory Committee, International Project Awards Committee, Student and Young Professional Activities Committee, and many more. Sourabh currently serves as Honorary Secretary and Treasurer of the India Chapter of American Concrete Institute. He is actively involved with the chapter's activities and is a supplemental examiner for the ACI Concrete Field Testing Technician Certification course. He earned his BS from Illinois Institute of Technology, Chicago, and his MBA from SP Jain Institute of Management and Research, Mumbai.
Thank you for that introduction. I hope all of you can hear me clearly. It's a pleasure to be here with all of you this evening, and a great effort that BAI and CE&CR are doing together for the industry at large. The topic today is one of the most relevant and interesting topics typically in the current times of the COVID-19 pandemic, in terms of social distancing and lack of manpower, resources, and who better, or it's an honor for me to introduce Dr. Bishwajit Bhattacharjee. I mean, who else could we ask to talk to us about this kind of a topic? Dr. Bishwajit Bhattacharjee is a very eminent professional in the civil engineering fraternity. He is Emeritus Professor at the Department of Civil Engineering at IIT Delhi. He obtained his BTech honors from IIT Kharagpur, MTech and PhD from IIT Delhi. He worked with Messrs. Gammon India for 2 years after his BTech as well. He is a nominated fellow of the Indian Association of Structural Engineers and a member of several professional bodies, including ICI. He has been involved with a lot of academic activities with several international institutions such as EPFL, Switzerland, University of Dundee in the UK, University of Dresden in Germany, and Catholic University in Belgium. He is also involved with industry as a consultant and also in training initiatives. Dr. Bhattacharjee has supervised over 172 MTech and 26 PhD theses till today, and currently is guiding 7 ongoing PhD research projects. He has published more than 180 papers in journals and conferences, and is active on numerous national committees involving DST, CBRI, BIS, NCCBM, etc. A biosketch of Professor Bhattacharjee titled A Teacher and a Research Worker under the feature People is available in the August 2012 issue of ICJ, and also under the title Gems of Structural Engineering in CEFI. Dr. Bhattacharjee is a recipient of the ICI Lifetime Achievement Award North 2012, and also actively is part of numerous editorial boards, including the Magazine of Concrete Research, International Journal of 3 Hours, and has been regularly invited as a guest editor for ICJ. So with that, with no further ado, I mean, I welcome Dr. Bishwajit Bhattacharjee, and sir, we look forward to hearing from you today on a very interesting topic and relevant topic in today's times. Thank you.
Thank you very much. Thank you. I hope I am audible to everybody, and
Yes,
I'm visible
yes.
as well.
Yes, you are.
Let me share the screen. Yeah, this is the screen. So is the screen now visible?
Yes, it is visible.
Right then. Okay, thank you. So let me go straight away to the talk that I have. Potential of industrialized building construction in boosting housing market in India. So basically, if you look at Indian housing scenario, this is based on census of India. These data are available. 33.29% are urban houses and 66.71 is the rural houses. But that was 2011 because census is yet to come. 2021, COVID has stopped all that. And the share of occupied and vacant houses are also shown. Urban housing shortage report from technical group 2012 NBO, and you find 2.27 million houses which are living in obsolescent, it's in obsolete houses. Non-serviceable kacha houses, of course, are also there. 14.99 million household living in congested houses, etc., etc. So this is a scenario, and this comes from total homeless people and so on from 2011 census. So urban housing shortage has been, and also rural housing, has been well recognized. And this is coming from the technical group. Shortages are shown, 7.41 million, different varieties of houses, EWS, UG, MIG, etc., etc. Economically weaker section, lower income group, middle income group as defined by National Building Organization, that is Government of India. So some sort of housing problem, 18.78 millions, according to government records. Well, according to 2011 census, 121 crores, that is 1210.98 million, urban 31.16%, and 78.48 million is the stock, right? Rural, urban, that's what is given. And actual shortage is much high because there are dilapidated houses. So there's a housing shortage that has been well recognized by everybody. And slums and squatter elements, of course, is very well known. Now, my purpose was actually we looked into a study by JLL, Jones Lang Lhasa, Mayank and Nanavati, their paper, and it shows that you have got demand and supply. That's what they are showing, share of demand and share of supply. And also simultaneously, they have written affordable capital value of the people. And if I join them by the lines, what I see is that, this is at this point, at this particular point, the demand reduces, but the supply, beyond the supply, takes over. That means you've got a lot more houses in this zone, demand is less, and actually they're vacant. So that's the scenario. So if you're, so that's what, so this prompted us to look into, in fact, there's something else also, housing for all schemes and all that came. So since in the very initial phase, as a part of IIT Delhi, I also had an opportunity to attend one of the meetings on housing for all. And I thought housing for all should need more, more kind of a investigation and study. And we did a study. Of course, one of my students did. Two of my students' work I'll be presenting. So demand line is shown here, supply is shown here. You have high demand on the lower side, lower supply, and obviously vacant houses, plenty. So let's see what is housing affordability, because it is that level, that is that sector where you have got a lot of demand. Can this market be attacked? We'll see that. That's what we're trying to see. So affordability has been defined as the ability to purchase and retain adequate amount of habitable space with access to basic amenities, absolutely basic maybe. This from international literature. We did a survey, and the literature survey of affordability starts with uh, Adam Smith, Engel, and Frederick Engel, and all that, old economists and socio-economists to recent time even. So therefore, there is very much it is there. So it was thought that 1 week's pay for 1 month's rent. Now, if somebody can pay the EMI as rent, then one will be able to buy the house. So effective ratio of housing expenditure to income works out to be nearly 0.25. That's what there. So this should be linked. That means, and this is the one thing. That means that somebody who can afford a house, by the way, not to be given by anybody. It should be linked to poverty line basket, because poverty line basket is one which is related to nutrition. So one just getting the nutrition, able to spend on nutrition, is not going to buy a house. No way. Not even going to retain it. So I call this as, we call, not I, it's already there, poverty line basket, PLB. The literature calls it. PLB includes household requirement for nutrition. And then it has been, in fact, this is the literature from which I got, they took it from perhaps from Western standard, that you need additional 2/3 of the same for other necessary expenditure. Which means that you need 1.67 times, this is the PLB, poverty line basket, plus 0.67, 2/3. And if you have more than that, that means 75% is this, then extra 25% you can spend on paying rent or even for paying for a house. So divide this by 0.75, we get 2.23 of PLB is the income required to afford a house and retain it. That's a fundamental. So therefore, those which are above this line will form the market. In addition to this, there are other issues like livability. Transport is one of the things. Workplace, employment opportunity, that plays a role. And this may affect the, for example, if the travel expense is too high, it may affect the affordability. One thing I have left out is the land cost here in all this, because land cost is very highly variable, and quite often it is jacked up because close to the urban area, close to work and things like that, that does, those kind of factor effects. So traditional materials and community involvement in community housing have been attempted. And the Chinese and Brazil, they have demonstrated some innovation blending modern techniques with local material for successful affordable houses. But that's limited. That's not very great. That cannot happen in a big way, right? Sorry, that cannot happen in a big way. One successful effort reported, of course, is Aranya Community Housing Project in Indore, because we are looking at the Indian scenario. There are many places where possibly the state has tried to give houses right from 1970. They have never been successful because it is the community, to the community it was not affordable. They'll sell it or rent it to buy nutrition. So that community we are not looking into. That cannot be the market. Above that is the market, and there's the upper limit of the market also, that's what we're going to say. So, but all these scales of these projects are very small. They're not large scale projects. And remember, we just talked about 121 million population. You think of its 1%, it is about 12%. 12 million. 3%, 36 million. So percentage wise, when you look at the absolute population is pretty high. So mass housing and large scale construction for economy, reduction in materials and production costs, this is the requirement, optimal multifunctional design and industrial construction, and speed and construction quality. That's all. Standards of affordability has been studied in India also by some people. For example, this is EWS, economically weakest subsection in LIG. This is 300 to 600 square feet. And they said that, okay, it's the rent or the EMI, expected monthly installment, 30%. Or cost of the house to income ratio is 4 times the household. Annual income, MIG, 1200 square feet and above, 40% of the household gross monthly income should fall to the rent or estimated monthly installment, 5 times household gross income. So, five times household gross annual income they'll be able to spend onto the house. These are the kind of reports available, standards are available. Below poverty line, of course, they said it's 2690 income category in rupees, and EWS should be per capita or whatever it is. I don't know exactly this, but these are the data that we could get hold of. Affordable to pay rent, affordable to pay cost of house, multiple annual income. There's only one income, this one is there. The median multiple is a ratio of the median of the house prices to the median of annual income of a house. That means median means 50% of the time. If you have a lot of data from annual income of houses, so from that ratio also, some people have earlier calculated. And based on that, this Deepak Parekh task force did 5 times annual income, 5.1 times, then severely if it is 5 times, people will not afford it. If it is 320, they'll afford it. Anyway, we thought we will look into this in more systematic way. And that's why we did this literature review. So monthly per capita income expenditure, based on that EWS, that's what been suggested, and total shortages has been shown in this ranges, right? MIG and so on. So what is the shortage? Housing shortage in millions, estimated number of households existing, in household in 2007, shortage also is this. So percentage shortage is 99% and so on. So similarly, income level, size of dwelling unit, these are from Government of India, NBO, and so there's some source from which one can get it. But I'm not really interested much in this. The minimum requirement is a minimum requirement is based on just hygienic condition, livable. You don't have to have great comfort, but you can design them for thermal comfort and things like that. Sanitation and hygienic issues, that should be there. And carpet areas for LIGSAT, this is what it is. So this zone, there are a lot of vacancies. Cost of house such that EMI does not exceed 32%, that's what I said earlier also. And it should be located within 20 kilometers of major works place. That's what it is. So goes to a little bit of city planning as well. But anyway, I'm not really looking into this. Is our literature survey we did to look into. So basically what we thought was that realistic market survey from all this should account for expenditure capability. So affordable housing lies above this PLB of expenditure or 2.23 PLB, poverty line basket. The PLB values we could collect from NSSO, National Sample Survey Organization. I think it must be based on Rangarajan or Tendulkar Committee's report. At that point of time, it was set at 973 for rural and 1.1407, that is 1,407 per capita per month respectively in urban areas. So if it is 2.23 of this, that means this month 2,170 rupees per month per person and 3,138 per month per person are the affordability limits for housing. So ALH If that is it, below that, nobody is going to buy a house, or they cannot afford it, simply. So that population you have to leave out. The market cannot do anything for that, unless their affordability or expenditure capability improves. So with less expenditure capability, house given to them externally likely to be disposed of, double F should be, or of in chalega, in sale, or at best on rent, because they'll buy other things which are required, maybe nutrition. So give a house doesn't solve any problem. And this has been tried and this didn't work. Instead of self-occupation, house will be used to trade off for necessary expenditure on the minimum calorie intakes, basic amenities, and other more important primary needs. So that population you have to leave out. And we have to find out how much is this population. And we have to find out the upper limit of how much is this population. So we are trying to relate the EMI, estimated monthly installment, to the fraction of population that's available state-wise. Actually we have done, although I'm going to show you, for the whole country. So maximum feasible number of housing units fruitfully affordable for people in a given region is population having an expenditure capacity greater than affordable lower, affordable lower, what we are saying, affordable lower limits for housing. Affordable lower limits for housing. Also affordable expected monthly installment or estimated monthly installment should be 25% of the monthly income. And that's why this 2.23 comes. There's an upper bound. The reason is why there's an upper bound. There's an upper bound because there's a lot of places where there's surplus. That's what we saw through that graph. The demand coming and the supply is there very much. So there are a lot of surplus, and that's the upper bound. So if somebody is looking only for the costly houses, new houses are not going to get, they won't be sold. All that it can sell is, of course, a few can sell with a lot of gadgets, because modern gadgets, electronic gadgets, a lot of intelligent system and things like that are coming. So if that is the thing, already existing houses, you can retrofit to those, they can sell. But otherwise, the market is very limited. They'll sell, but the market is limited. And that's why there is a real estate, I believe real estate market is not really possibly expanding as it was expected. So we have taken expenditure capability of 2011 census, and it is available in terms of monthly per capita expenditure, MPC. I'll call it MPC from now onwards. So, expenditure capability is easily available in census. All census it has been available. And that's what I came to know from my friends in the Emeritus Department Economics, and that's why I picked it up. Because I thought, there's something, there is a fraction where it is affordable house and where possibly there's a market. And below that, if you say housing will be there for those people, it's not going to be there. You might give them a house, they'll sell it off, buy nutrition or something else, or rent it. So maximum feasible number of housing units fruitfully afforded by people in a given region should be population having an expenditure capacity greater than, this is the same one coming, upper bound I just said. So this is, yeah. So this would fit it for Indian population based on those expenditure capability, that data that was available to us. We have just fitted the curve for all the country. That's the cumulative percentage. MPC stand for monthly per capita expenditure capability. Per person, so per person per month. And the blue is for rural, this is for urban. This is available for every state also. But starting with, I'm just looking at the country. I'm not going to, I have in one of our publication, which is a recent publication in Current Science. It's a journal, it's a very well-known journal published from India, Indian Academy of Sciences, Bangalore. From there, they publish it, and it's well-known internationally. So basically, it is there it has been published, and I'm just giving a part of it here. This is for rural. This is for rural, right? So few states I have just taken, looking at this value as highest. I mean, it might just be happening that, so all that, let me explain it a little bit, because otherwise many of you may not be science engineering background at the current level. You might have studied it earlier. 95% of the population having expenditure capability per person less than 6,500 per month. 95%, but 5% is very large. Remember, 5% is very large in absolute number, maybe population of many countries. So don't get scared. Oh, is it 95% below 5? And if you see rural, it is 3,000, right? So that's what it is. All right. So let's see. This is, I picked up the maximum value. That's of all the states. That was Haryana showing this extreme 12,000. It might be all jolly well for places like Gurugram, but doesn't matter. I'm not bothered about that. Which is the highest I picked up? They're all there. This is rural, something like this. And I also picked up, nothing against any state or anything of that kind, just for the sake of showing you that I have graphs, similar graphs for every state. So I'm taking the range, extremities. That's what we do in science, scientific experiment. So Bihar had 3,500, and this is how it is. Other states falls in between. So that's the kind of, so these curves can be obtained from the census data. And then this is cumulative, 95% below. So if I want to find out what is called percentage of population at a specific MPC, then these are called all India again, percentage of population. And I have to take an algebraic term called log. Some of you might be familiar with this, because you see it varies from 500 to 5,000. So scale is too long. So if I take log, then it gets 10, 5,000 is, 1,000 is 3. And 10,000, log of 1,000 base 10,000 is 3, 100 is 2. So they get scaled down actually. Logarithmic, algebraic, well, anyway, you have to bear with me. This is a little bit of algebra will be involved, but not much. I'm not going to that. So differential, or, at individual log of these values, MPC, how much is the population percentage, that could get it. But I'm not going to talk about this anymore. But even that was not enough for me to do the scientific exercise. This log MPC was too small. If you see this log MPC, this is of course 10 log MPC multiplied by 10 I had to do. If I take log of 3,000 I get 3. Log of 1,000 I get, sorry, this I get 3. This is 4.7 or something like that. 100 I get 2. 10,000 I will get 4. So they are small numbers. I have to multiply by 10. And that I call as E. 10 multiplied by log of MPC. I have devised my own scale, and that you must be hearing. Some of you must be hearing about noise, dB, decibel. And that's also in logarithmic scale actually. Many things is evolved actually varies over a large range, and then and also possibly there are more. I don't think I'll go into the physics and maths of those ones. So I had to take it algebraically. Many times we do log, right? Take log, and that's what it is. So E, I am defining a variable, new, I'm calling it new, which is related to MPC. So E versus, when I plotted this population, cumulative, the earlier graph, I plotted it now with respect to this, and I get the urban like this and rural like this. This percentages remain same. I have not changed this. Only these values have become now 38 instead of something like 7,000, and this has become 28 instead of something like 500-600 or whatever it is, right? So this is how it is. This is how I just changed them to this variable, and this is, I can fit a curve to this equations. Those who are from arts background, they may not understand, but you must have all known in management science also, if there's an independent variable, something else, for example, uh, number of webinars now happening in this month may be a function of COVID severity or something like that, number of COVID cases. So we relate things. So in physics, of course, science, maths, including concrete science, we do it quite often for many things. So these relationships are available, and this we could fit into a relationship. I'm not going to tell you how to do it, not interested. But we used what is called, there is a software called CarbExpert that will give you, Excel will do many things, not many, maybe it may not be a complicated curve. So you could fit a curve, P is this, fit curves to this. For each state we have found out this, A, B, and then there's a term C, all this we found out to the power C. This terms we have found out for all the states, this is there. So somebody wants to do these calculations for any state, when we finally find out the market might be interested. And then differential rate of change also we have found out. So anyway, I think considering the time, I'm not going. Now, that, the affordable lower limit of housing from the earlier calculation is 2170. Rural, I think I have made this calculation somewhere earlier. Did I do it, or it's not missing? It got missing or something? I did calculate them. I did calculate them somewhere, or it would be there. Yeah, 2170 and 3138. And if I take these values here, if I take these values here, then, and take E, calculate according to this, then E comes out to be 33.4, and for urban it comes 35.4. So this 33.4 is here, 35, and therefore, you see, 89% of the population may not be able to afford a house in the rural India. And by 2011 statistics, census statistics, and 77% of the population of India may not be able to afford a house. But 23% itself is very big. So 33, that's what I'm saying. Population works to be 89 and 77. And thus maximum available market for housing would be 11%. And 23% urban population of India as a whole. Now 11% means 14 crores, so more than 14. And 23% also would mean double of it, 28 crores. That's pretty high. There's a surplus supply over higher income population correspond to monthly income per capita expenditure capability of 8,500 from that graph that I showed. And if I take per capita income, so this was per person per month, monthly annual family income is 5 lakhs 1,000. They're the people who might be having a house already. So what we do is, this population are not our market. So 99.8% of rural population have an income lower than that. That means most of the people have income lower than that. That means my all 11% is available as market. And 97.5% of urban population have an income above this. So 2.5, 100 minus 97.5, I subtract that from 23, 20.5% of the urban population has got, there's a market, total market in the country. State-wise, you can find out. Now, EMI is 25% of this per capita per month. And if I, for 5-member family, if I consider, this is a payable EMI. That's a least value. If they can afford this, then they can buy a house, both in rural and urban India. And if it is required 15 years as repay period with 9%, that's the government stated interest rate for this kind of housing. Its present cost can work out. Land cost I have left out. I'm assuming the land cost, you have to add or do something, whatever it is, very variable thing. So I didn't take. Taking 9% as interest rate, monthly interest rate would come out to be this, and for 180 months, so 2.67 lakhs is the house cost with minimum hygiene and minimum things. The person who can, the family that can pay, they can afford a house. Anything below is not workable because it is simply not, they will not be able to hold the house. So this is delta P0. So my market starts from here, from this, the construction and, and accommodation cost. And highest is this, the upper limit. And since MPC multiplied by 5 people into 0.25 is my monthly installment, thus MPC is 0.8 EMI. So EMI can be linked to MPC. EMI can be linked to MPC, and population can be linked. Population 0 is here, and anything up to maximum limit is here. So I can limit this, link this population, the market, that is the market available, to EMI. And that's what we have tried to do. Right? So population fraction representing potential maximum size of the market corresponding to small, that we can find out. Right? So that's what we did. I hope it is not, this is repeating. This was the last one. Yes. So delta P, P delta E calculated. So we actually calculate delta P above this population. And from our mathematical expression, we could calculate out and plotted the graph. So delta P is the population available in the rural area as a function in total country. State-wise, this can be done. This is done, part of it. Equations are available, given in the paper. So therefore, based on this, the E values versus this delta P is given. And E is this. So MPC you can find out from this expression. And then EMI you can actually find out from this expression. That means EMI with respect to population, one can find out using this sort of curve. That was for urban. This is for rural. There's an equation. Simply you can use in Excel sheet and find out. So this can be calculated. So that's the first thing. So lowest performing, now this is the first thing. So the market is there. Actually, if you see, let me just take it here. Supposing 4% market here, 4% markets or E values corresponding to some MPC, some EMI, you can find out 2% market. If you go to higher values, market reduces because already people have got house. Lower values markets are there. So 2% of the country's population, 3% of the country's population, that's the market. Population fraction as market. So this is a delta P population because you have removed those populations who can't afford. Remove that population who has already got houses, surplus people. So in between, maximum is on the lower side that we have seen from JLL study also, and then we just algebraically fitted it. And you can find out that supposing your MPC value is, this E value is 36, corresponding to the EMI also you can find out 4% is the population, is a market, 4% of the country's population, which will mean 56 crores, no, not 5.6 crores. 140 crores. So 1% is 5.6 crores. That's not very small. And between the ranges also you can find out. So that's the kind of possibilities there. But then you have to, only thing is that it has to be mass housing, large scale construction for economy, material and production cost, optimal multifunctional design and industrialized construction. If you want to give minimum thermal comfort, it has to be multifunctional. The structure itself should be able to do all this function, more than one function together, and obviously speed of construction quality. So only industrialized and specialized material construction that can do this job. And I of course say concrete will be a major component, industrialized construction with concrete, because it's an extremely versatile material. If you look at the material side of it, this is a drawing of material side of it, a sketch for material side of it. You can have a large number of binder options, right? This side fiber reinforcement, that's for high-end concrete, of course. But I'm not saying high-end material you will not be using. You might be using. I don't know what is the kind of ones to look into. So you can have a OPC here as a binder, OPC, then water, OPC and water, that form the binder. OPC, water, maybe silica fume, maybe geopolymer, maybe what do you call resin binder. There are all possibilities are there. It only shows possibilities. There are all kind of fiber reinforcement possible, from steel fiber to polypropylene. They have their specific purpose. This stops bleeding. This gives you better fracture resistance and so on. There is all kind of skeleton or aggregate system could be there. Recycled aggregate, manufactured aggregate, simply quartz and 6 that's used in high performance or reactive powder concrete. So you have actually quartz and 600 micron down, right? That's what you use together with OPC with silica fume binder and some sort of super plasticizer, hyper plasticizer, and steel fibers might give you this. So you can see that range. You can design composite system, concrete composite system, and you can have its performance again in a 3-dimensional matrix. So x-axis shows its moldability, what you call rheology sometimes in scientific terms. And you have from zero slump to self-compacting concrete. Mass concrete to 200 MPa reactive powder concrete. Versatile, very, very versatile. But then it has got problem, ductility, and you can make composite out of it. Together with steel, you can use, service life can be very, very long. It can be designed for all this. So you see, concrete industrialized construction is a thing which you can do. These are linear system, allomatic. This is hollow core slabs. I'm not going much into this. This is offsite construction, which we know that this starts from the design. Everything is done in the manufacturing, done offsite. I'm not going to discuss this too much today. And then site works, installation, transportation, and all that. So that's offsite construction and offsite manufacturing cycles. Something like that, construction design, everything drives other one, right? And people, process, technology, all involved everywhere. Examples, plenty. Precast concrete structure being assembled. This has been, some of this is being done in India. It's not that it's not done. 3D modular, steel modular, increasing construction efficiency through modular, because examination of construction performance. Obviously, capital cost is high. Labor skill, I'll talk about this quickly. I do not know how much time do I have. Extent of breadth of the, so I'll take about 15 minutes, 10, 15 minutes, not more than that. If that is there, hope it is there. Is this there? Is the time there for about 5, 10 minutes or so? Yes. Mr. Praveen? Yeah. Okay, I'll go ahead. So quality and all you'll have pretty, you can control. Cost is reduced because of individual cost will be reduced beyond a point, of course, called break-even point. There are plenty of benefits, shorter construction schedule, greater degree of predictability, and so much. You will get plenty of literature on this. I'm not going to talk about this. So useful parameter is, of course, labor cost, material cost, and plant cost. There's something called C factor. This is there in one of my article in CE&CR. Right, this is there in pre-cap. So something called C factor. Cost of skilled labor, cost of concrete delivered at site, the ratio. And another is P factor. Cost of a crane. This some or other has become a picture. I'm not able to edit it. So cost of hiring a typical crane for a day. And cost of one-day skilled labor. So this product of these two has been seen to be constant. I'll come back to this. Product of this has been seen to be constant, 10, for many countries when compared. Now you can see this. This is for various countries, right? This is for various countries. Korea, for example, this is 2. They use 10% cement in precast. So industrialized construction, obviously, all precast must be industrialized. I'm talking about buildings. Obviously, bridges. You can have site plan, for example. So precast, right? may not be industrialized construction. Industrialized means you are selling it also. There are three types of precast thing. One is the site, temporary, like for a bridge. There's semi-permanent, like casting yard of Delhi Metro, but that's not for buildings anyway. And permanent was Hindustan Prefab or many other companies now which are involved, Pune particularly, or many other places, even Delhi, there are a number of them. So, but they have to be a factory to sell it. They have to see the market. So it has been seen that P factor where it is high, this is low. Southeast Asia must be India. Where C factor is low, this is low. P is a cost of crane, no? So that's what it is, cost of crane, cost of hiring a crane or equipment, say a representation of equipment. Where this is low compared to others. So Scandinavia, they use 70%. And that's what it is. So we have this cheaper, we think it is cheaper, but in the long run, perhaps we have other kind of problem. But you have to develop those people, skilled people, manufacturing and things like that. This has got other benefits I don't think I'm going to talk about. Wages vary. Cost of concrete doesn't vary much. And proportion of cement used in precast industry is higher with higher C factor. That's what it is. This proportion of cement in the construction, precast industry. So this species has been seen to be 10. And if we have to improve this, we have to see that possibly, indirectly, perhaps somewhere somebody, the state or consortium of people should train people. Cut down on the unskilled people. Increase their skill. So that they earn more, but then earn with using a machine. Well, these are the thoughts. The Builders Association are the better judge of this kind of thing. They know their economics. They can make a consortium or something, think about it more. I'm just inducing, triggering off, sparking off a thought in their mind that there's a market somewhere. Other thing is that cost increases as house area increases and quality increases. Quality may be even specification someday. So you see the cost increases when square meter increases per house. But then we are looking at affordable housing only. It reduces when this reduces. And when you improve specifications and quality also improve, but quality is a minimum quality you have to maintain. So that's also increase the cost. There are some fixed cost. Outside, there may be something more. Anyway, this is from their work. Actually, industrialized construction can cut down on supervision cost, 19%. Logistic, 22%. So the cost reduction can be there is possible. So economic gains, saving of cost, non-economic gains, as creation of additional usable space, etc., etc. Shorter construction would enable shorter construction time will enable realization of rent. Higher flexibility in building design, and you can combine, the functional design with the structural. Aesthetic, etc. can be also handled. So there are grading, which type of alternative, what is a benefit, might be a subjective, can do by management tools like analytical hierarchy procedure. You can find out weightages. P, the particular type of alternative. W are the weights, and P is given grade by expert for an attribute for a particular IJ. IJ stands for a particular type of alternative technology, materials plus technology. So VJ, and you can compare and find out which is best. There's something called analytical hierarchy procedure used by managerial science, using managerial science. So there are issues of benefits. Saving time is one of the important things. Also, what happens is that there'll be no fouling of, HVAC may not be there in affordable houses, but electrical services surely would be there. Fouling, the two teams will not fight. They work in each separate space when it is off-site construction, off-site manufacturing, precast system. So one can actually find out, estimate site preparation, etc., initial time, number of work groups. So if M is the number of work groups, N is the number of modules you are operating on, K is the maximum pace in days. That means This group 1 might require 7 days, 2 might require 10 days. So you take the maximum. So, and you can calculate out K is a, pace is same in days per module. You take the maximum and work sequences by group. So you can actually find out the amount saved would be related to delta T time saved. C is the project cost, right? So interest rate also you can bring in, etc., etc. Better quality, standard deviation is lower maintenance cost, longer service life, and even you will save on your cement consumption, therefore cost, because you will reduce down the standard deviation. So there is a break-even analysis required, optimal capacity for your capacity. If you go beyond capacity, there's a problem, right? So you see this is the fixed cost, and this is the revenue increases in this manner as your product increases, and the cost increases. There's a fixed cost for cost increases, but cost per unit finally would reduce when you produce a number of them. Similarly, benefit per unit, profit also can increase if the price is fixed. So anyway, this if this is anyway getting recorded, so you'll have the slides. So average unit production cost, etc., is given. So we did some, global. Okay, this is the last possible on those. Finland uses maximum. Scandinavia is saying. India is somewhere here. Percentage precast consumption worldwide. If you look at it, Finland is maximum. Germany, then Russia, UK, etc., etc. So we did some studies for economically weaker section and took the HUDCO and CBRI's building plan. I'll quickly go through this because I think I have nearly 1 hour I would have finished. Total area. So what we did was, I think I'll not go into details of this. Total area is 628 meters square. Thickness is there. We thought hollow core slabs one can use. Size of the bed we took is this. This is typically the one that I think Limatic supplies. Perhaps there are 1 or 2 plants around Delhi, close to Rajasthan border, and there is one in Noida and all that. So my students were collected from either from those places. Yeah, I think he collected from those places, and some of those data might have been from LNT. So all these are there. So so based on all this, the cost is calculated. Price of the extrusion machine, cost, etc. Variable cost have been land rent and everything is calculated. And then the cost of cast in situ RCC slab then we calculated, right? And total fixed cost required for hollow core slab we looked into, and we tried to find out only slab part we are looking at in this break-even analysis, then separately for column. So we find out the precast slab cost initially, production per meter square as it increases, the cost beyond this point, this break-even point, actually it is lower. So we calculated, some of you might be familiar with break-even numbers or break-even analysis. So we found out through this 11,418 meters square, or if 18 number of EWS building, 4-storied or something like that. Then for wall, right, again we did the same thing, same analysis, and we found out materials cost of partition wall, etc., we found out. And ACC block, AAC block, autoclaved aerated concrete block, we found out. And this break-even analysis we did vis-a-vis brick wall, and this is what it shows. So precast wall, this it could give. AAC block is here, and brick wall. So beyond this point, so you can find out the break-even numbers again. AAC is thermal insulation anyway. Similarly for columns, and details you have collected from site, right? And cast in situ column information obtained from RCC column, so we just obtained from sites actually and did break-even analysis. So it shows that 75 number of buildings if you are building, this is break-even. And for brick, how many number of buildings were there? Average production, no, this is not the one. For bricks, number of buildings, 5 number of buildings or 3 number of buildings, etc., etc. The orders are something like that. So something like EWS building 75 number of buildings, it might break even for hollow core slab and those. But for each other ones, one has to do the analysis. So slab, wall, columns, and all of them we looked into, and then we found out that what is a break-even cost for each type of one, and that's certain. So I think here I stop. Any questions? Of course, I'll answer. What we have seen is we have been seeing that there's a market available, but not at the highest level. Possibly, you can go slightly above the lowest level, middle level, there are available. But there are issues. State-wise, it would be available. And possibly, I don't know what is the logistic, how one goes about. But there are a lot of possibility of people have the affording capacity if you bring down the cost. And this can be done by industrialized construction. Not only that, it can do optimal multifunctional design. You give both. So therefore, it can really boost the housing scenario in case of concerted effort by all stakeholders. Thank you very much.
Thank you, Dr. Saab. That was, a very, very interesting perspective. I thought that we were going to be here for a civil engineering presentation, but that we, of course, got quite a bit of that. But there was a lot of focus on the macroeconomic factors and why is it important. That's why it started to analyze that what is the current situation in India with respect to population, resources, affordability, things like that. So it was wonderfully sort of introduced, and then you got into industrialized construction and the importance of that for a country like India. So of course, I will talk to you as well. I would like to ask you a few questions as well. But in the meantime, if anybody else also wants to ask questions, you can type it into the chat box, and then I will ask or request Dr. Bhattacharjee to answer those questions.
Sure.
Yeah, Dr. Bhattacharjee, now in terms of, you mentioned that in terms of Finland and Singapore and Russia and Germany are quite successful or at adopting industrialized construction or precast building technology. So could you please give us some insight on typically what is the number of floors or the number of stories of these buildings in these countries?
No, they are going much higher, in fact, because their
Okay.
needs are different.
Yes.
But I am saying that, what I am trying to point out, that perhaps your market is not there to that kind of high-rise scenarios. There is another problem with the high-rise scenarios. I think we have done, I am not a policymaker, but this is my own understanding from building sciences, building engineering and concrete technology, science of civil engineering and all that. By increasing floor area ratio, you have done actually a much more dangerous thing towards the environment. You have increased the car density, traffic jams, you have increased the pollution level. Even I'm not very sure, in Mumbai, the converting those textile mills in a systematic way to housings, did it do a really good job? Or we should have been sticking with the old planning concepts of satellite townships, Navi Mumbai and all that. So that kind of scenario, I think that planning, I don't think at least in Delhi, I find the moment they increase the floor area ratio, that creates a lot of problem. So people tend to, because they would like to, the prices of the land goes higher. Why concentrate people in one area? There's a good old Delhi's master plan. If you look at early plan, it had satellite cities. Gurgaon, now Gurugram, Faridabad, then Sonipat. Some of those satellite cities were converted into industrial cities by the state government themselves because they wanted to take the benefit of this. So then the NCR came into being. So my point is that one must look into an integrated approach. Whether I should go for high rise or not, that's $1 billion question. But I just only try to show there's a market somewhere. And it is not on the high end side. It is somewhere, not exactly absolutely on the lower end side. It was somewhere in the middle. And pushing up the FAI for growth or something like the steel and cement consumption, I'm not sure that is the best idea. Although there may be, other kind of debates onto this. I was trying to do a computation for Delhi. Unfortunately, COVID came. My student couldn't go survey. How many number of vehicles increase would have taken place after the FAR increase and things like that. So high-rise buildings were there. You see, the Singapore, for example, it has 6-7 story building, or maybe much taller buildings they've gone. But I think I'm not talking of that really.
Okay. And something else that is I was particularly keen to understand is that, of course, industrialized construction, precast, pre-engineered buildings, steel structures, they all, of course, are coming in more and more. But also, typically, like say India or Singapore, we have quite a heavy monsoon or heavy rainfall. And that is why, of course, you talked about skilling, and that a lot of focus needs to be on skilling also of the manpower. But I'll come back to that question a bit later. So what are certain tweaks or modifications or enhancements that we can do in basic
No, see
engineering
the
design?
yeah,
Yes.
yeah, no. So the approach has to be not only onto the structural design. You see, when we are talking of buildings, it's the most complex of infrastructure. You talk of bridge, it's only civil engineer, and transportation engineer finishes the planning part of it, and civil engineers will do the job, even if it is, obviously, if it is, let us say, it's a box guard or RCC, PSC bridges, elemental, segmental construction, civil engineers do all of it. Electrical engineers would be there to maintaining the casting yard, electricity, and then finally they'll come to erect those electric poles, a little bit of here and there. 80 to 90% will be civil job. You come to hospital, not even 30% is civil job. HVAC, the avoiding cross contamination in hospital through HVAC, and such things are so much. And even if it is residential building, you'll have all kind of services coming in. So it's different trades actually. So it's the most complex of all the structures. Now there you cannot think of only structural design or only one aspect. Normally tradition has been, the functional aspect has been left. And traditionally architects would do whatever conventional practice is. The science goes very little into it actually. I have architect students also. Eventually in our programs, master programs, we have architects also. And I have been, number of my masters or even PhD students have been architects. So it has to be an integral thing. Structure, architecture, everything. The performance, waterproofing. Sunanda Chemical is known for waterproofing. So chemical, construction chemicals, they are all part of technology and we can solve them. That's not an issue at all. I do not think that's an issue. Right? Either both science is available or the practice is available. Some cases, science is very strongly available today. We understand many things.
Yes, that was very apt answer. Yes, it's not just civil engineering. It is so many different things coming together to make it successful, of course. But it is the need of the hour, industrialized construction. I don't know how much time we have, but I am myself very interested in this topic. I am still probably have about 70 or 60% of my career still ahead of me. But yes, so in fact, this morning I was myself at a precast plant just to understand more before I moderate the session. So anyway, if Dr. Saab, from your experience or studies, one part is of course environmental factors, but all of us here are typically either developers or from the construction companies who are part of the audience today. So is there some sort of guidelines or advice, guidelines that you can give us that typically learnings from past? Of course, there's lot of advantage in industrialized construction or precast construction, but just some guidelines on what are some things that we can do to make it, you talked about that precast is say 31% more cost effective as compared to in situ. So that itself is a large incentive for us to sort of switch to industrialized construction, because finally economics also is what is very important in governing this change. So I wanted to ask you two questions particularly. What can we do in order to ensure that, I mean, bring it to as successful as possible? This is our precast project, certain precautions that we can take. And apart from that, also in terms of actually achieving a 31% or more, a higher, I mean, better sort of cost effectiveness as compared to in situ construction. So if you could please shed some more light on that.
No, my problem is, you see, the field data is not with me on these issues. In fact, I have
Okay.
introduced this to you, giving you to think about it. That's all. That's my job.
Yes,
Now
yes.
you think, if you have a problem, if you think that I can help you out, I can help you out. But at the moment, we started looking at, when I looked at some of the slogans of the good old days. So I thought that, is it possible to have housing for all in this country? That was the first question I was asking myself. Then I started looking into the census data of 2011. That's what is available. Unfortunately, 2021 data is not available. Somebody asked me a question. 2011-12 data I have presented because we did analysis on that. But currently, this is not, data is not available from census is not available. So really, I cannot look into it, right? But I'm not sure it would have changed positively very much. May not change negatively, but positively also not very much. It wouldn't have changed because percentage we are talking of. We're not talking of absolute terms. So population would have increased and percentages would have remained similar. Little changes here and there maybe, but the methodology is still fine. So I do not know how to go about to answer your question that what is the advice. No, I'm sorry, I can't give you advice. I'm only asking you to think that there's a market somewhere and industrialized construction can give you. How do you do it? How the state helps you? How do you make a consortium of many of you to come in? That's your business.
No, no, definitely. You have spurred a lot of thinking today. There's no doubt about that. Dr. Saab, actually, another something else that comes to my mind right now is that typically in these COVID times, manpower was a big issue, manpower shortage. And that is where the immense advantage of industrialized construction is that since it is being sort of manufactured in a factory, there is some sort of reliability or in terms of timelines and things like that. So that's a very important factor. So could you, I mean, please, I mean, if you have some data, could you share some light on typically in terms of cost saving? You said 31%. In terms of time, typically, what is the advantage? How much can we sort of save in time in precast and industrialized construction?
Often I'm not able to tell you, but it can. I have given you a formula to calculate out.
Yes.
Right. So it will depend upon the process to process actually.
Yes.
Process
Okay.
to process. I can see in the chat box one question which I like to, answer: unemployment. Somebody has put in, displace the manpower and increase the unemployment. In my opinion, it may not. It may do it other way around because your volume of activity will increase. The growth might increase, in fact, if you are able to tap that market which is not captured right now. The growth might actually increase and a lot more people their skill would change. But in India, nobody, like HCC does some skill development program, L&T does, CITC does, Dr. Fixit, we were trying to do, I was also involved with Dr. Fixit in their governing council for a while. They were trying to do for repair people some training and all that. But that's actually peanut. You need a lot more skill development centers. May not need that many number of civil engineers. I'm not sure. That has to be somebody has to survey. But skilled people are very much needed. And if you shift the unskilled to the skilled, their purchasing power will increase, in fact. That might boost overall scenario. So the socio-economist has to think about it. I did a little bit of survey and I just put forward my thought. And I thought that industrialized construction can help in this way. I asked the top economist, I think recently he was delivering lecture at IIT Delhi. He did not answer my question. Actually, perhaps he didn't have idea because in US they don't face this kind of situation. I was asking, is industrialization of construction activity, which actually employs maximum number of people after agriculture, unskilled people. So will it change the scenario, economic scenario. He, of course, couldn't answer this kind of thing. Neither I am able to, but one socio-economist, they have to actually analyze this. There may be a potential, I'm not sure.
Okay. So, Dr. Saab, I think there are too many more questions for you, but we may not have enough time. It's such an interesting topic and such an interesting perspective that you've given us. You've definitely spurred thinking, and I'm sure all of us, I mean, as I mentioned, are leaders at construction companies and the construction industry, and surely this will benefit the country and the construction fraternity at large. Your lecture today, you talked about so many. I mean, you gave us so many different models. What is a C factor and your own models, in fact, C factor, P factor, the
C
cost
was not
benefit.
my model. C is taken from a very recent book, actually.
Okay.
Uh, so C and P factor, these are international. I don't have that international. I mean, I got it from literature. But the other model, the population model and all that from Indian data, that is our.
Yes, some wonderful work. I mean, a lot of work and effort and time has gone into your studies. What was very, very also important is that, I mean, you talked about how precast and industrialized construction will significantly improve durability and service life of structures, which also, I mean, is important in, I mean, typically this DCTA's law of fives is if you spend $5 today, you can save $125, say 10 years, 15 years, 20 years from now. And that is what exactly is required in a country like India, where how much ever you try, skilling of manpower, I mean, has to be done for sure, but it will take a long time, and that is where industrialized construction also will sort of be very beneficial in terms of improving service life of structures, and which you covered very well. You talked, I mean, definitely to us about comparison of precast slabs versus in situ and precast columns versus in situ, and similarly, of course, hollow core slabs. A very, very interesting perspective you gave us, and of course, you showed us which are the countries which have been doing this in the past. So I think with that, from our end, I mean, from my end, I would like to thank you for sharing your, I mean, a lot of knowledge with us from so many different aspects, economics, civil engineering. So I mean, a whole lot of so many avenues. So with that, thank you, sir. We look forward to many, many more lectures and presentations from you
One
like
question
this.
somebody was asking about steel. I am not ruling out steel, by the way. Steel 3D modular is also there. So no partiality to any material this side or that side. It's the best you take best. Everything is very good and very bad, depending upon what you are using. So you got to know about it and use it appropriately. That was the point. Well, are you ready in India for this? I want you to be ready. Somebody has asked this question. Is the cost comparable to conventional wall? Yes, that I have shown you that you can, provided your volume is large, and there is a large volume available. That's the point. I want to think. I gave a perspective so that your thinking process at least starts. You start thinking in that direction. Possibly, you can think. Maybe if it is, do more exercise and find out whether it is really good. So I just wanted to induce that thinking. That's my purpose at the moment.
Thank you, Dr. Saab. I mean, you
Thanks.
definitely have achieved that for sure. Thank you very much. And with that, I wish you, I mean, a good evening, and I hand it over to the organizers, please.
Now, I would request Mr. Anirudh, Honorary Treasurer of Builders Association of India, Mumbai Centre, to present a few words for vote of thanks.
Good evening, ladies and gentlemen. It was indeed a very informative lecture given by Dr. Bishwajit Bhattacharjee, and in his coordination, very subtle and proper questions asked by our moderator, Sourabh Manjrekar. I formally thank everybody attending this series of webinars, and particularly the participants who were at the tune of almost 90 to 100 in numbers today for this particular seminar. I thank our chairman and Revered media to initiate this concept and bringing to the light, and in such a wonderful webinar, which is putting light on potential of industrialized building construction in boosting housing market in India, where as Doctor has explained us how population and type of construction impacts the affordability concept. I formally thank Dr. Bishwajit Bhattacharya, Mr. Sourabh Manjrekar, and Trisha Bhattacharya, and I thank everybody for being present here from Builders Association of India. Thank you. Thank you so much.
Thank you.
Thank you.
Right.
Thank you. Thank you. Have a good
Okay.
night. Bye.